Okay, so here, remember, reference angles are only going to be acute angles because we know how to use our trig functions with acute triangles. All right, so if we have something bigger, we can create a smaller one called a reference angle. And so the way we can find this, so if our reference angle is in this quadrant, the second quadrant, we go here. All right, in order to find what this little reference angle is, we just take the full 180 degrees and subtract this angle. So if we take all of this, subtract that angle, we're left with this. All right. This one's the most tricky to conceptualize. So if this is our big angle and we want to come back and make this smaller angle, we need to take our bigger angle and subtract 180, and we're left with the smaller part. And then finally, if you have a reference angle in the third quadrant, so here's our big angle, we are going to take the full rotation, 360 degrees, get rid of our big angle, and we're left with the small. All right, so it takes practice to get this down. Remember, reference angles are acute, less than 90 degrees. All right, so we want to determine the reference angle, so we're just finding the angle, the small one, for each of the following. So let's start with theta is 45 degrees. In what quadrant, 1, 2, 3, or 4, is 45 degrees in? It's in the first quadrant, which means it is already less than 90 degrees. So the reference angle is just a 45-degree angle. And so when we're talking about trig functions, we can use this triangle. All right, let's do something with a little more work. This time, our angle is negative 73 degrees. All right. First of all, we don't want to work with negatives. Let's get back between 0 and 2 pi. All right, so what do we need to do? We need to find a coterminal angle to 73 degrees. How do we find a coterminal angle? We just add 360 degrees to 87. Why did we do that? We did this to help us determine what quadrant this angle is in. We're not always sure where these negative and these big numbers are, but if we can put it between 0 and 360, we can find the quadrant. All right, so here, what quadrant is it in? Should be in the fourth quadrant, right? All right, so here's 270, here's 360. That angle should be between those two. All right, so it's in the fourth quadrant, so that means our angle looks something like this. And our reference angle is this little bitty thing. So we can make this triangle. And so the question that we're asked right now is, what is that little bitty reference angle? How do we find it? Well, we take our full 360, subtract the 280, or 287, and we're left with our reference angle. So 360 degrees minus 287 degrees is 73. So positive 73 degrees is our angle. It's an acute angle. That's our reference angle. All right, let's do another one. Negative 915. Oh, I think I need to stop recording soon. Okay, we first need to get it on our unit circle so we can know where it's located. All right, so negative 915. Goodness, I can't get that right. We need to add 360. That won't be enough. I'm going to add it again. Still won't be enough. I'm going to add it one more time. And we get 165. Perfect. We are now on our unit circle. We can figure out what quadrant this angle is in. All right, so what quadrant is 165 degrees in? Should be in the second quadrant, right? 165 is between 90 and 180, so it's in quadrant 2. So here's what it looks like. And the thing we're trying to find now is the reference angle. So how do we do that? Well, we can take the full 180, subtract 165, and we're left with what we want. And so our acute angle, that is our reference angle, is 15 degrees. Okay. All right, so I know this looks kind of foreign, but keep practicing and maybe rewatching the videos with practice. It will become a little more familiar to you. All right, so now let's do this when we have radians. Okay. So something that I like to think about when I have radians is rewriting things. So for example, 0, pi over 2, pi, 3 pi over 2. I can write this as multiples of pi. Right? So this is 0 times pi. This is 0.5 times pi. This is 1 times pi. This is 1.5 times pi. All right, so this will be helpful. You'll see in a moment. Okay. And then also, maybe I'll also write 2 pi over here as well. Okay, so next, we want to determine the reference angle for 19 pi over 6. So it's difficult when we're in radians to figure out where we are. So what I like to do is just divide the numbers. So 19 divided by 6 is 3.16. So that will be more than 2 pi. So that means we are bigger than what's on our circle. Okay, so that means we need to subtract 2 pi to get back into our circle so we can know what quadrant we're working with. So 19 pi over 6 minus 2 pi. You need to get a common denominator. Seven pi over 6. Okay. All right, we'll see what 7 divided by 6 is. It's about 1.1 something. All right, so that should tell us, maybe I'll write that over here. 7 over 6 is about 1.1. All right, so 1.1 goes here, right? It's between 1 and 1.5 pi. So we are in the third quadrant. So here is what our angle looks like. Starts here, ends in the third quadrant. And so then we care about this reference angle right here. Okay. All right, so how do we figure that out? Well, we need to take this full angle here and subtract 180, or pi, to get this little angle. All right, so 7 pi over 6 minus pi. Going to get a common denominator. Pi over 6 is our reference angle. Alright, so I'm going to stop the video here, give you a chance to marinate about what happened here, and then we're going to move on to the next example.